Okay, so we were talking about basic concepts in organic chemistry, right? Organic chemistry. Okay, so with respect to last class, can anyone tell me what we had discussed in the last class? Can any one of you? Yes, good morning everyone. What we had discussed in the last class, can any one of you tell me? Okay, Anupama Patil. From which place? North Karnataka, I think. Okay, resonance effect. Yes, Gauri. We were discussing about resonance effect. Very good. Okay. Now we were talking about resonance effect. Yes, Harshita. When I'm talking about resonance effect, so what do you mean by that? Which type of molecules will show the resonance effect? Especially those organic compounds which are having conjugated double bonds. Which are having conjugated double bonds. They are the one which can show the resonance effect. Okay, which are having conjugated double bonds. Or if you don't want to use the conjugated word, then you can tell alternate double bonds. We can use the word alternate double bonds. Okay, now alternate double bonds. See, for example, if I take benzene ring, that's where we can see alternate double bonds. Double bond, single bond. Double bond, single bond. Double bond. So that's where we can tell that it's a conjugated double bonds, or we can tell that alternate double bonds. So due to that, benzene can show the resonance features. Benzene can show the resonance features. So any molecule which are having alternate double bonds, they can show the resonance features. All of you have understood? Got my point? So this is majorly due to delocalization of electrons. Resonance is nothing but delocalization of electron, and it is a permanent effect. So what do you mean by permanent effect? Permanent effect means until this molecule is existing, this effect will be there. That's why it is called as permanent effect. Okay? So there is no question of temporary. No requirement of any reagents or any attacking agents. Then only the resonance effect? No. Resonance effect will be there whether attacking reagent is there or any other reactant is there or not. Benzene ring, whether it is having any substituent or no substituent, still it will be having resonance features. Same as that of the hyperconjugation. If you recollect, same as that of the hyperconjugation, which is also one of the example for resonance, which is also one of the example for permanent effect. Okay, so when I am talking about resonance, to be more particular, in the last class we have discussed about which type of resonance we have discussed in the last class. Anyone? Resonance effect? Yes, we were talking about resonance effect. In resonance, which type of resonance we have studied? Can anyone of you tell me? Hmm? Which type of resonance? Positive or negative? That's what I'm asking. Anyone? Aniline, benzoamine. Yes, Gauri, they are examples. I'm asking which type of resonance. Yes, what you have written is correct. We have discussed with respect to some of the examples where we took the examples of aniline, absolutely correct. Then I told same thing we can observe even for phenol or even for chlorobenzene. Yes or no? And even for methoxybenzene or alkoxybenzene. Methoxybenzene, which is also called as anisole. Which is also called as anisole. They are all examples. But I am asking which type of resonance, that is positive resonance. These are the examples where they will show positive resonance. That's what we have discussed with respect to last class. Right? So, when I am talking about positive resonance, yes, Rohan, I was thinking, I was not saying your name. I thought you are absent today. Yes, Rohan, it is positive resonance. Okay? So, when I am talking about positive resonance, based on the example, can you define what you mean by positive resonance? So, positive resonance is nothing but where there will be movement of electrons, where there will be movement of electrons towards ring structure or towards benzene ring structure. Anything is fine. So towards the ring structure. So that's what positive resonance talks about. Right? So if you observe clearly, it will be initiated. It will be initiated when lone pair of electron, it will be donated towards the benzene ring. That's what movement of electron towards the ring structure from the substituents. So from the substituents. So that's where we have the positive resonance from the substituents. Then it is called as positive resonance. So which is that substituent here? That is amine group. Amine group is the substituent where electron is moving away from the amine group, or simply you can tell movement of electron away from the substituent. Then it is called as positive resonance. All of you have understood? So this is aniline I have written. Same way we have phenol which will show same category. Chlorobenzene which will also show similar properties. And alkoxybenzene where I have taken the example of anisole, methoxybenzene. That can be, even that will show the positive resonance. So in your examination if they ask, define positive resonance with example, then you should go with the example with diagram depending on the marks. If it is asked for 3 marks, then you have to write the all the different types of structures. Okay? Otherwise, just define, give the example for 2 marks and all. Okay, now? All of you have understood? So that is positive resonance. Okay? So any doubt with respect to last class? If you have any doubt, you can ask. Any doubts? Okay. Done. Okay. Okay. So then we will come to negative resonance then. We will come to, as I told, they are important. Even in hydrocarbons topic, you will come across this one, negative resonance. Naturally, in the name itself it is there. They are exactly opposite to that of the positive resonance. So however, what will happen? There will be movement of electrons. There will be movement of electrons away from the benzene ring. Since we are talking about benzene derivative, that's why I have written away from the benzene ring, or movement of electrons towards the substituents. Anything is fine. Towards the substituents. Okay, so that's where it is called as negative resonance. That's where it is called as negative resonance. Hagadre, if I want to give the examples for the negative resonance, I can take one of the example as NO2. So what is this? This is nothing but nitrobenzene. This is nothing but nitrobenzene. Even nitro group will be used as prefix. So nitrobenzene. Okay. Same way. Another common example will be. Can any one of you tell me which is this molecule? Okay, which is the substituent before that? What is the name of that substituent? Which is that functional group? Can anyone of you tell me? What is the name of that functional group which is now present on the benzene ring? Can anyone of you tell me? Name of those substituents? Yes, very good. Very good. That is carboxylic acid. Yes, that is carboxylic acid. Shashank. Okay, it's in urgency have type. That is carboxylic acid. Okay. So when I am talking about carboxylic acid, name of the molecule should be ended up with this functional group. Right? So carboxylic acid always it will be used as suffix, not as prefix. It will be used as suffix. So therefore, since it is attached to the benzene ring, we can call it as benzoic acid. We can call it as benzoic acid. Now benzene became benzoic acid, OIC acid. Right? That is due to carboxylic group. Okay? So that's why we have the benzoic acid. Now we have another one. Another common example. CHO. Okay. So which is this functional group? Can anyone of you tell me? So which is this functional group? Ashish, he is telling ketos. So first thing, we don't have ketos, Ashish. It should be ketones. N is not there. Okay, Shashank, aldehyde. Yes, it should be aldehyde. Okay, na? So it should be aldehyde. Aldehyde functional group. Okay? Rohan and Shashank. Shashank has written Ashish. It's not ketones, it is aldehydes. Now when I am talking about ketones, I have carbon attached with the oxygen. Then it is called as ketones. Where these two substituents should be R and R. It should be other than the hydrogen. They should be other than the hydrogen. Then it is called as ketone. If any one of these are, if it is becoming hydrogen, then it is nothing but aldehyde. Like this, it will be aldehyde. So ketones, aldehyde. CHO. Same thing, I can write it as like this also. Right? Same molecule, one and all same. Aldehyde, same logic is applicable here also, where I can write carboxylic acid like this one and all same. Okay? All of you got my point? In that case, what should be the name of the molecule? It's the aldehyde functional group. What is the name of the molecule? What should be the name of the molecules? Yes, Ashish, very good answer. It is benzenyl. It will be benzenyl, Al, or simply you can call it as benzaldehyde. Benzenyl, of course, or you can call it as benzaldehyde. You can call it as benzaldehyde. Al, benzenyl. Al talks about aldehyde. Aldehyde has the functional groups. Okay, all of you have understood. So these are some of the examples. These are some of the examples which will show the negative resonance. Which will show the negative resonance. All of you have understood? Any doubt in this? These are some of the examples. I have taken common examples. These are some of the examples which will show the negative resonance. Okay? Fine. So any doubt in this? Okay. So I will go with one of the example for explanation. Okay. So Rakesh, what you wanted to type? Okay, na? Okay. Then I will start with I will take the example of nitrobenzene, which is there in your textbook also. Okay. So now when I am talking about nitrobenzene, so this is how the attachment will be. Okay, now? Now, if I want to take it out, so that's where I have nitrogen. Okay. It is actually showing the coordinate bond. It is actually showing the coordinate bond. So 1, 2, 3, 4, 5. Now due to that, it's going to make the bond with the carbon of the benzene. Got my point? And that's where we have the nitro group attached to the benzene ring. Nitro group attached to the benzene ring. All of you have understood my point? Any doubt? See, when I'm talking about this one, so it will be left over with 6 electron as it is, because this electron does not belong to oxygen, it belongs to nitrogen, which has invested. It is a coordinate bond. It is a coordinate bond. And when it comes to this oxygen, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5. Nitrogen has invested all of its electrons. So that's where we have the nitro group attached over here. So this is actually a coordinate covalent bond. It is actually a coordinate covalent bond. No need to tell sorry Rakesh. Just I am asking. Okay, so that's fine. Okay, that's where we have the nitrogen. Try to understand all these things. So if you observe here nitrogen, it has invested all its electron. No electron, no valence electron is left over with the nitrogen. So nitrogen will be having highest oxidation state. Nitrogen anyway, in the redox reaction, you will understand this concept. In this case, nitrogen will be having highest oxidation state because it has invested all the electrons. It has invested all its electrons. So therefore, it will be at highest oxidation state. Okay, so therefore this nitrogen is very upset. Oh my God, I'm at my highest oxidation state. I don't have any electron. Instead of that, I have invested my electron in the bond formation. So this nitrogen is upset. Okay, and about that, this oxygen will be torturing the nitrogen. Always remember, whenever oxygen will make the double bond, this oxygen will behave like a mad person. So once it will make the double bond, at other time it will tell, no, 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 I want to take back my electrons. That's what this oxygen will be torturing the nitrogen. And nitrogen is also with positive highest oxidation state. So due to that, it will try to pull the electron from the benzene ring. It want to try to pull the electron from the benzene ring. Because this oxygen is torturing the nitrogen. So first it will tell, okay, we will make the double bond. Then it will tell, no, 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 I will take back the electrons. So therefore, this nitrogen is under confusion state. So therefore, it will be having affinity towards the electrons. Fine? All of you got my point? So due to that, now starts the resonance. Due to that, now starts the resonance. This oxygen, it will pull the electron from the nitrogen. Because all of us, we know that oxygen is more electronegative compared to nitrogen. Yes or no? Oxygen is more electronegative compared to nitrogen, because in the periodic table, see here, that's how you should apply the periodic table concept. So nitrogen group 15, then comes the oxygen. After the nitrogen, oxygen will come. That means oxygen is smaller in size compared to nitrogen. And all of us, we know, as the atomic size decreases, electronegativity is going to increase, right? So therefore, this oxygen, it will not listen to nitrogen. Actually, you give me the electrons, it will tell. So therefore, since nitrogen is more electronegative compared to carbon, so now it will give torture to this carbon. No, no, no. This fellow is taking the electron. I can't give. I have already invested my electron. Give me the electron. That's what this nitrogen will tell to this carbon. Now, poor fellow, what this carbon will do? It has to listen to the nitrogen, because nitrogen is more electronegative. So due to that, it will take the help of neighboring carbon, because they are having double bond, right? So it will take the help of neighboring carbon. See, my friend, this nitrogen is giving torture to me. So please give this 5 electron to me. So therefore, due to that, there will be movement of electron like this. Please observe how I am showing the arrow. When you are showing the arrow, it should be perfect. Sorry, it should be perfect. Okay. So that's how the movement of electrons will be started. Now we have a condition. We have a condition where there is a double bond, because this double bond will be shifted here. So nitrogen, oxygen, and oxygen with minus. Why minus? Because both the electron is taken by the oxygen. Both the electron, even one electron which belongs to nitrogen is taken by the oxygen. So therefore, minus. Okay, na? So now, to nullify this loss of one electron, this nitrogen has made the bond with, double bond with this carbon. Now, who is the loser actually? Huh? Who is the loser here? The loser here is this poor fellow. This carbon is the loser. So therefore, it has lost one electron. So due to that, it will take positive charge. It will take the positive charge. So negative, positive. And all the other double bonds will remain same. All the other double bonds will remain same. Okay. Now, poor fellow, this carbon, which has become now carbocationic form. That carbon has become carbocationic form. So therefore, it will be torturing to neighboring carbon. It will be kind. Oh, I lost my electron. Rohan, why suddenly you remembered about college? Really, I don't have any idea. Maybe or may not be. We have to wait. Still, time has not come. We have to wait. Okay? But why suddenly in between the classes you remembered about the college? Right? Even I want to see all of your face, no doubt. I want to see my students also. But anyway, we will wait for some time. Okay? Fine. So that's why we have the carbon which will be gaining positive charge and oxygen will gaining the negative charge. All of you got my point? Why this negative and positive? Now, in a hurry, students will forget to write the positive charge. Then naturally, I am going to deduct 1 marks. Naturally, I am going to deduct the 1 marks. In a hurry, they will not write the positive charge. So it's wrong. I cannot give complete marks. I will have to deduct the 1 mark. So therefore, you should be careful with respect to the arrow and with respect to the charge. Okay now? Now, since this carbon is crying, so this neighboring carbon will try to help it out. It will try to help it out. It will tell, don't worry, I will invest electron. We can make the double bond. Don't cry. Now, due to that, now there will be another structure, double bond nitrogen, oxygen minus, then there is a double bond because this double bond has been shifted here. Now this carbon got positive charge. This carbon has received the positive charge. Now this carbon will be crying, oh my god, I lost my 1 electron. So due to that, this neighboring carbon, it will try to make the double bond. It will try to make the double bond. And that's where we have the nitrogen, oxygen minus, then we have the double bond over here. Now this carbon got the positive charge. This carbon got the positive charge. All of you got my point? And at the end, once again, there will be rearrangement. So once again, there will be rearrangement. So finally, we are going to have the structure where double bond O, then we have the double bond over here, double bond here, double bond. All of you can see here. If you go with the first one, if I want to number it, 1, 2, 3, 4, 5, 6. Least number should be given to that carbon which is attached to the substituent. So this carbon will take the least number, that is 1. Either it can be 1, 2, 3, 4, 5, 6 or 1, 2, 3, 4, 5, 6. Anything is fine. Now same way I will give 1, 2, 3, 4, 5, 6. If you observe here carefully, what are the double bond positions? Double bonds are present between 2 and 3, then 4 and 5, then 6 and 1. That is the double bond position. What about here? So in the examination, this one not required. So to make you understand, I am writing this one. Otherwise, it's not required. So here it is 1 and 2, then 3 and 4, then 5 and 6. Can you see? There is a change in double bond positions. In the exam, when you are writing the resonance structure, no need to write at the end double bond positions and all. It's not required. It's not required. Okay? All of you have understood? That's where we have the double bond positions. That shows the resonance features. So therefore, nitrobenzene can be shown as like this, or it can be shown as can be shown as all are correct. All are correct. Okay, since there is a continuous shift in the double bond position, that is due to delocalization of electron. So that's what that circle indicates. Circle in the center of the ring, that's what it indicates. Got my point? So that's why we have the negative resonance with respect to nitrobenzene. And same logic is applicable when it comes to benzaldehyde or when it comes to benzoic acid. So they are all other examples which will show the negative resonance effect. Any doubts? Any doubts in this? Fine. So there is a change in the position of the double bonds. And be careful when you are showing the arrows, and be careful when you are showing the charges. Wherever is applicable, you have to put the charge. Okay, now? Otherwise, you are going to lose the marks. So that's where we have the negative resonance, and I have taken the example of nitrobenzene. So you can practice with the benzoic acid or benzaldehyde acid. Any doubts in this? ಹಾಗಾದ್ರೆ where this particular concept is applicable, naturally, as I told, this chapter and hydrocarbons, they're all, if you understand properly, you can dominate the organic chemistry, which students normally feel difficult. Okay, students normally feel difficult. Now whatever I'll be telling now, it is not related to resonance features, no need to write these things, but try to understand whatever I'll be telling now, because it will help you out in writing the organic reactions. So don't by heart any reactions, try to understand, then practice. First you should understand, then practice, then only you can master the chemistry. All of you have understood? So ಹಾಗಾದ್ರೆ I have a substituent, it can be anything. Okay, now I have a substituent. If this is a benzene ring, numbering waste. But if I have a substituent attached to it, I have a substituent attached to it. Now that substituent can be either chlorine, okay, so or either it can be a amine group, okay. So these are some of the examples, or it can be OH group. Anything is fine, where X can be any of these substituents. Now, if you go back to yesterday's class, and if you come to regular naming the positions, then I can tell whenever a substituent is attached to benzene ring, this is called as ortho position, this is called as meta position, and this is called as para position. Try to understand it properly. It will be helping you out in writing the reactions. So when there is a substituent, whether it can be any of these three or any other substituent, whatever it might be, now we can have the position as ortho ortho, meta meta, and para, because benzene is a symmetric in nature. So half here, same thing. But my point, what is O? O is nothing but ortho positions. So this is also ortho positions. Sometimes you can make prime. So this is meta positions. So this is also meta positions, and this is para positions. So this is para positions. So listen to me carefully. Now listen to me carefully, and I have shown what can be the X. Here, what can be the X? It can be chlorine, it can be amine, or it can be OH. All of you got my point? Now, I have nucleophile. Which part of this molecule nucleophile is going to attack. When X is chlorine or amine or OH. What is the speciality of this substituent? What is the speciality of these substituents? Which type of resonance it will show? Any one of you? Which type of resonance it will show? Whatever substituent I have shown, which type of resonance it will show? Positive or negative? Shashank is writing it as negative. All of you are agree with him? All of you will agree with Shashank? Whether it will show the negative resonance? Yes, Bhumika, you are absolutely right. Shashank, Gauri, no. These substituent will show the positive resonance. If you remember, which we have discussed in the last class, a chlorine or an amine group. I took the example of aniline, right? So they will show the positive resonance. Don't get confused. So therefore, organic chemistry, how to practice, that is the only secret. Nothing else. You should understand, then you should practice. Don't by heart. So hagadre, all the substituents, they will show the positive resonance. They will show the positive resonance. Okay? Okay. So in that case, which charge will be present on the ring structure? Positive or negative charge? Which type of charge will be present on the ring structure? That's fine, Shashank. Okay, which type of charge will be present on the ring structure if that is the case? If they are showing positive resonance. If they are showing positive resonance. So in that case, which type of charge will be present on the ring structure? Whether it is positive or it will be negative charge. Anyone? Yes, Shubhangi. Yes, Anupama. Already people have written. Oh, that is for older one. Yes, it will have the negative charge. It will have the negative charge, if you remember. So that's where I can see the presence of negative charge at these positions. Okay, at these positions, I can see negative charge. Yes, Gauri, you are right. Ashish, yes, they will have the negative charge due to the positive resonance. Hagadre, you should tell me if I have a nucleophile, which part of this ring structure it should attack? Which part of this ring structure it should attack? We have a nucleophile. So what do you mean by nucleophile? They are electron-rich species. Nucleophiles are those which are electron-rich species. So which part of the aniline, which position nucleophile has to attack? First. So that's how, if you understand this one, you can apply all these things to your chemical reactions, organic chemistry reactions. So which part of the ring they are going to attack, and these things you are going to study in your hydrocarbons topic also. Whether they are going to attack the ortho or meta or para positions. That's what my question. Which part of the ring nucleophiles they are going to attack? Ortho, meta or para. You can just mention O, M or P. Ashish, beautiful answer. Yes, it should attack. Yes, all of you correct. It should attack meta position because that's the only positions where electron density is less. If this position electron density is high. Very good answer. So therefore these nucleophiles they can attack here, they can attack here, okay, but here no, and here no, and here also no. So therefore, under this condition, aniline with respect to nucleophiles, it will act as a meta-directing molecule. It will act as a meta-directing. That means it is directing these nucleophiles to the meta positions. So aniline, as the example I have taken, same thing will be applicable for chlorobenzene also. Same thing can be applicable even for other molecules like phenol also, where they will be meta-directing for the nucleophiles. All of you got my point? This is the reason. This is the reason why they are meta-directing. Any doubt in this? Yes, go. I will explain. So many arrows I have shown. So many arrows I have shown. It will be confusing. I will remove the arrows. Okay. Now, what I mean to tell you is, I have a reagent which is a nucleophile, which is an electron-rich species. Now, I am incubating that reagent with the aniline. Now, which part of the aniline a nucleophile is going to attach? That's what I mean to tell. Now, nucleophiles are electron-rich species, so therefore they will not go to electron-rich area, right? Electron-rich, electron-rich. No, no, not matching. Okay, so therefore they are going to attack the meta positions. They are going to attack the meta positions because this is the only region where we have less electron density. Electron density is more at ortho and para positions. At ortho and para positions, right? But at meta position there is no negative charge. That means electron density is not rich. It's fine. So in that way, nucleophile is going to attack at this particular region. So therefore, under this case, I can tell that it is meta-directing. It is meta-directing with respect to nucleophiles. So with respect to nucleophile, when nucleophile act as a attacking agent. Okay, all of you got my point? Anyway, these things one by one you are going to study in organic chemical reaction, organic chemistry, in hydrocarbons also. Okay, fine. So I have a electrophiles. I have got a electrophiles. Electrophiles means what? Electrophiles are those which are electron deficient species. Electrophiles are those which are electron deficient species. So which part of the ring they are going to attack? Whether it will be ortho or it will be para or it will be meta. Which part they are going to attack? Anyone? Which part of the ring they are going to attack? Which position? Yes, Ashish, very good. They have the options now. Either it can be ortho or it can be para positions. Either it can be ortho or it can be para position. Any of these three regions they are going to attack because electron deficient, electron rich, right? So in that case, with respect to electrophiles, I can tell that ortho and para directing. Ortho and para directing. Okay, when it comes to nucleophiles, it is meta-directing. And when it comes to electrophiles, it will be ortho and para-directing. That is with respect to those substituents which will show the positive resonance. Which will show the positive resonance. All of you got my point? So this is how you can apply these concepts in the later part of organic chemistry, even for second period. You can apply these concepts. So that's why nucleophiles, they are going to be meta-directing, and electrophiles, it will be ortho and para-directing when we are talking about a substituent which will be having or showing positive resonance. Fine? Any doubt in this? Any doubts in this? If you have any doubts, you can ask. Oh, yes. Done. Then in that case, I will move to the another one. That is negative resonance. We will move to negative resonance. Okay? Negative resonance. For negative resonance, I will take 1. All the other things will remain same. So Y will be equal to, either it can be carboxylic acid, or it can be nitro group, or it can be aldehyde group, anything. Okay? So these are the substances which will show the negative resonance. It will show the negative resonance. So what will be the charge on the ring when I am talking about a substituent which can show the negative resonance? Can anyone of you which can show the negative resonance? What will be the charge present on the ring structure? It will be distributed, charge in the sense, it will be distributed throughout the ring. So which is that charge? When I am talking about a substituent which will be showing the negative resonance. Yes, Ashish, it is positive charge. Very good. And if you go back to the resonance, that's where the positive charge is localized at ortho and para positions. It is localized. Yes, all of you correct. It is localized at ortho and para positions. Now you can observe here, I have a nucleophile. I have a nucleophile. Now it is exactly opposite compared to earlier case. Now nucleophiles are electron rich. So therefore they are going to attack ortho, para and ortho positions. All of you got my point, because nucleophiles are electron rich species. They have to go there where electron less is there, electron density is less. So that's why they will attack the ortho and para positions. Ortho and para positions. Got my point? So therefore, when it comes to negative resonance, observe here carefully. Nucleophiles will be ortho and para directing. Or the nucleophiles, they will be ortho and para directing. Yes, Gauri, very good. It will be ortho and para directing. Okay? Now, naturally, we have to discuss about another reagent, that is electrophiles. Another reagent, that is electrophiles. Now, when I am talking about electrophiles, which are electron deficient species, so which part they should attack, or to which part they are going to attach? Anyone? We have electrophile, electron deficient species. Which part of the ring they are going to attack? Whether it is ortho or para or meta positions. Which part? Any one of you? Yes, Shashank. Yes, all of you correct. Yes, Gauri. Ashish, it cannot be ortho and para. Ortho and para, already positive charges are there. So positive, 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 they will repel. So naturally, electrophiles, they are going to attack the meta position. So therefore, when it comes to electrophiles, they are meta-directing in nature. They are meta-directing in nature, exactly reverse compared to positive resonance substituents. For negative and positive, they are exactly reverse. All of you got my point? Any doubts in this? Okay? Any doubts in this? So I can give one table also to make it easy. It's very easy actually. Only thing is you should practice. That's all. Okay? So now I will make two columns. In first case, I have the condition where I have the negative resonance. Negative resonance. Okay? And on the other side, I have the positive resonance. Okay? Now, here the first column will be attacking agent. Attacking agent. Okay. So if it is a nucleophile, attacking agent is a nucleophile. When it comes to negative resonance, it will be ortho and para-directing. It will be ortho and para-directing. But when it comes to positive resonance, it will be meta-directing. It will be meta-directing. And when it comes to electrophiles, negative resonance, it will be meta-directing. You can observe that. It will be meta-directing. And in positive resonance, it will be ortho and para-directing. Ortho and para-directing. All of you got my point? So when it comes to electrophiles, with respect to negative resonance, they will show the meta-directing, but positive resonance, they will be ortho and para-directing. Okay? Yes, Rakesh. No, sir, understood means what? Okay. Fine. So try to remember all these things. They are all fundamentals. Fundamentals for the organic chemistry. So if you are perfect in this, in future, whenever you will come across the organic reactions, you can guess the product. If it is wrong, initially it will be wrong. When you guess the product, initially it will be wrong. But if you understand the concept and if you are guessing, then most of the time it will be correct. Then you can feel very happy. Oh, I am done properly. Then only you can master this organic chemistry. Otherwise, it will give you a lots of torture in future. And students will feel organic chemistry, very, very bad subject. That's what they will feel. Any subject you take, if you understand the concept, you will enjoy. Otherwise, you will hate the subject. And I don't want my students to hate any of the subjects. Okay? You should love the subject. Okay, na? Whether I am clear? Any doubts in this? So we have finished with resonance. So another two concepts are there. One is electromeric effect and another one is inductive effect. If I clear that those two, then the whole organic chemistry is done. Analysis and quantification and all, it is not there. It has been removed. Okay, na? Okay, then. So try to practice with other molecules also for negative resonance. Okay, na? So tomorrow we will meet. Thank you. Thank you very much. Okay, na? Bye.